Good afternoon, ladies and gentlemen. Thank you, AMS Weather Band, organizing this wonderful citizen science symposium. We are happy to be part of it. My name is Nicky Lam from the University of Hong Kong. I'm on behalf of CoWIN Network to share some of our recent progress on community network development and some study using the network data. CoWIN is a community weather network established since 2007 from the joint effort of Hong Kong Observatory and tertiary institutions. Currently, we have about 130 local schools in Hong Kong has joined the network, installed weather station at their school rooftop. What is good about CoWIN Station is that it is a community network with a large cover of urbanized area, providing valuable urban climate information beyond the existing WMO weather station. We measure temperature, pressure, relative humidity, wind speed direction, rainfall, UV, solar radiation. Like many community operating network, we have our peak participation a few years after the network was established. However, recent years, we have observed a dropping trend in our network participation. We believe that this may be caused by various reasons, including station aging, lack of maintenance, frequent change of responsible person, lack of activities beyond weather stations. To resolve that, we have started a new program called Make Your Own Weather Station using Arduino board. We also established STEM education through geography. And my student, Jeffrey Chen, will share some of our recent development on that in the next presentation. In the past few years, we are continuously seeking ways of utilizing the community network data for scientific studies. We have identified several applications, including urban heat island investigation, which is the focus of this talk, statistical downscaling from forecast model, local extreme precipitation event. You will see that since we have a large coverage of urban area with many stations, we are able to look at the spatial distribution of rainfall in a very detailed way. And last but not the least, we recently looked at the shock wave of Tonga underwater volcanic eruption. And our station were able to pick up some of those shock waves through our pressure measurement. Before using it for scientific studies, we first perform a quality control. You may see that on the left figure shows that the raw data, there are a lot of problems associated with data with negative values. We also find that there are some problems and some over and under prediction. And when after our performing the quality control, those problems has been screened out. In the quality control process, we apply 3 different methods, including seasonal threshold, pattern check, and spatial regression. For the seasonal threshold, we use the monthly mean average with standard deviation. In this study, we apply 5 standard deviation as the boundary to screen out any those very wrong data. And then we use a pattern check to look at whether the diurnal pattern were existed in those data or not. And occasionally we see that the stagnant data, which is what I mean is they are the same values, continue recording in the instrument. Those were removed by this process. And the third process is called spatial regression test. We selected 9 Hong Kong observatory stations and using spatial regression technique to construct their relationship. We developed the upper bound and lower bound for each individual hours for individual station. Any data outside of the range will be discarded. After cleaning up the data, we applied it, the data to study the effect of urban heat island. And the left figure shows you the Kowloon station in blue and red in Hong Kong Observatory Station. And solid line indicates the temperature and the dashed line indicates the changing temperatures. What we find is that the nighttime temperature dropping very slow in Kowloon Station and remain high throughout the night. Therefore, the reason of having higher temperature in urban area, not just because of the daily heat up, but also the heat was not able to dissipate out of the city before the next day. Here is another example. We applied our Kowloon data to construct a temperature distribution, spatial distribution of temperature. And on the left side shows you is the temperature difference between urban and rural, and which signify the urban heat island effects. And this graph here used all HKO station to construct this spatial pattern. On the left side, we add the Kowloon station, so you can see there are more refining outcome in this plot. Urban area are much warmer than the other places in Hong Kong. Besides using it for direct usage, we also use it for validation. And we perform a study using a low-cost sensor measuring temperature along different area in Hong Kong. Some are street level, some are more like on the sidewalk, etc. And what you can see that here shows that after the downscaling, the temperature are more distincted in the map. And we used Kowloon data to validate the outcome. In addition to that, we used Kowloon data to construct extreme heat threats. In Hong Kong, we often affected by tropical cyclone. In here we call typhoon. When typhoon reaching about 1,000 kilometers from Hong Kong, it creates a subsidence airflow, which making Hong Kong a very high pressure, clear sky. So it becomes very hot. And if we compare Hong Kong Observatory data with our Kowloon data, we can see that the probability of getting a very hot day and hot night in our data set actually more than what reported by Hong Kong Observatory. When we expanded the study to use NOAA heat index to look at whether we get more problem when we using Kowloon data. And what we find that it depends on the set of data we use. Kowloon data actually show much higher frequency of heat stroke than what Hong Kong Observatory report. Therefore, we believe that the station we measure temperature probably close proximate to the actual people, so it reflect better the situation than what WMO station show. Okay, so this is all I have uh, to share, and thank you very much. And the floor is open for question. Thank you very much.